So today we continue with the lab for subnetting. So we are going to subnet a/24 into two. So we're going to create two networks out of a/24 subnet using this topology, and we're going to divide. We're going to create this as subnet 1, section 1. This section 2, they're going to be divided with this router here. So for this topology I used a PC. Actually this lab is from David Bumble, so it's very easy to, it's a very good lab to understand subnetting, to understand the basics of subnetting, I would say. So without further ado, we'll start by understanding how to subnet this, how to divide this subnet into two. First and foremost, we need to, so this is the subnet we are going to divide into two. The key formulas we need to work with and to have in the back of our mind are this. So we have that. And one thing I like to use a Sunny table, which is very useful. I found it very useful. It basically so here you have subnet, you have host, we have mask. 1, 2, 4, 8, 16, 32, 64. Two, 5, 6 /24. This is a shortcut. So with this Sunny table, it makes it very easy. So here you can see the pattern is the subnet. We have this, the row for the subnet, which is 1 multiplied by it. I mean, 1, the double of 1 is 2, the double of 2 is 4, the double of 4 is 8, the double of 8 is 16, and so on. The double of 122 is 256. Now, for the host part, we start with 256. 256 divided by 2, it's 128. 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So, and the mask, it just goes up with an increment of 1. Slash 2040 slash 20 slash 32. So we use this subnet, this formula. Let's say we want to divide our network into 5. We make sure we have these two here in order to keep the result even, to have to know the number of network we can obtain, because we cannot obtain an odd number of, if we say we need to divide, we need 5 subnets, we cannot obtain 5 subnets like that. We will have to get 6 subnets, or we have to get 8 subnets, sorry, and out of the 8 we will use the 5 that we need and discard 3 which won't be useful, because we cannot obtain 5 subnets just like that. So that's the use of these 2 in this formula. So let's get to it. So we have this subnet. We are asked to divide into 2 subnets. The key here is 2 subnets. So using this formula, let's say equals to 2 raised to the power 2. So for this example, you use this subnet formula, 2 raised to the power n equals 2. Since we need 2 subnets, which is this, it will be /25. So we are moving from /24 to /25. So we are borrowing 1 bit. This /24 is 24 bits. We are borrowing 1 bit to make it /25 in order to have 2 subnets. So here, from this formula, n equals to number of borrowed bits. So 2, since we are borrowing 1 bit, 2 raised to the power 1 equals 2. So we have 2, in order to get 2 subnets, we will need a /25, which gives us a total number of hosts is 128. This host total, it's not usable host total. So that's it. So if we are asked what is the number of hosts, of usable hosts, we come and use this formula where -2 is we will remove -2 from here because we need one IP address to reserve it for the broadcast IP, and the second IP address for our network IP address. So since we need 2 subnets, this is what we are going to use from this table. So subnet, we call section 1 for our first subnet. Section 1 is 192.168.1.0/25 now /25. Section 2 192.168.1.1. you use this 128/25. So we have just divided this subnet into 2 subnets, which are this one. Yeah. So if say we are asked to have 9 subnets, we simply use this Sunny table. We come, okay, how many subnets do we need? 9. We come here, this 9. 9 is greater than 8 and less than 16. We cannot use 8 because 8 is smaller than 9. So we will be using 16 and get rid of 7. So that in that case we will use a /28, whereby we will have borrowed 4 bits. So borrowing 4 bits gives, and putting in this formula, gives us 2 raised to the power 4, which is 16. Now 16, in order to get the number of usable hosts, you just subtract 2 from it, which are the network IP, the network ID, and the broadcast ID. So that's the case if we were asked to create 9 subnets. But in this case, we're just asked to create 2 subnets, which I made it in section 1 for the first subnet and section 2 for the second subnet. So now let's go back to the lab and do some labbing to see. So the first task, subnet the current subnet, which we have already done, into 2 subnets with as many hosts as possible. As many hosts as possible is, as we've seen, it will be 128 minus 2, which is 126, which are these are the usable hosts. So this is how many, these are the total number of hosts we can have in each section, in each subnet. We have a maximum of 126 IPs. Maximum of 126 IP addresses in each subnet. So That's that for that. Let's come here. Now we will divide this and place this router there. In order to do that, we come here. No. We click here. Look at this. We bring our router here. Now click on connection. We can press on control. Straight through. First. Click. Connect. Just like that. Now, what we just did, we've divided physically this topology. So what we're going to do, we call this, as I said, there's section 1, and the IP address for that was 168.1.0/25. Subnet mask will be 255.255.128. So for section 2, one 192.168/25. So this is a network. This is the network ID of section 2, and this is a network ID of section 1. So first subnet on left, S1. So this is the first subnet here. Second subnet on the right, S2. S2 stands for the switch 2. So now we are asked to configure PCs with the first IP addresses in each subnet. So we configure this PC. Let's come here, configuration, IP address. So yeah, since we cannot use this is the network ID, so we can use any number here which is in the range, but for convenience purpose we use the first IP address available for this PC in this subnet, and we will change the subnet mask from /24 to 128 because it's now a /25. So to confirm that, we can come here, IP config. So we see that this is the new IP address and subnet mask. That's for PC1. Let's do the same for PC2. Configuration, fast internet interface. Now, PC2 is in section 2. This PC2 is in section 2 from here. So I will see that section 2, the network ID of section 2 is 192.168.1.128. 8. So we have to change that and use the first IP address available in that subnet mask, in that subnet, which is 1 to 9, and we will change the mask as well to /25. So that's it for that. So we've done task 2. On task 3, configure PC with the first IP address in each subnet. Configure the router with the last IP address in each subnet. So let's go into the router, CLI, enable, show IP interface brief. So this command shows us our interfaces on this router. We have 3 interfaces. We have 2 physical interfaces and 1 virtual interface. So the gigabit 000 is the interface connecting to S1, and the gigabit 001 is the interface connecting to S2. You can see that by just pointing on this router. Yeah. So, and we see they are all down. Let's configure conft interface gigabit 000 IP address 192.168.1. So now we are configuring the router as a gateway, and in each subnet the gateway is the last usable IP address of that subnet, the default gateway. So in this case, our router at this interface, it will be our default gateway for that subnet. So we use the last usable IP address before which is the IP address before the broadcast address in that subnet. 1 that will give 126. Now 255.128/25. So now one last thing we need to do, no shut. You see it has changed and it's now up. Go in, can go show IP interface brief, and you see that we've assigned successfully an IP address on this interface, which will serve as the gateway, the default gateway for this subnet at that interface. So we have to do the same for section 2. Also do the same for section 2. Go to config mode, interface gigabit 001, IP address 192.168.1. We use the last usable IP, which is 255. 255.128. No shut as well. Let's see how it turns green. No shut. See, it turns green. We can now go back and check. You see, we have configured IP address on our router. Now can just change the name of the router to R1. Yeah. And we can save it. So configure router with last IP address in each subnet. Connect router between switches, which is what we've done already. Configure switches with second last IP address. Okay, let's go to the switch. The switch is up by default. Show IP interface brief. Here, for the switch, we are not going to connect a specific interface. We're going to connect the SVI, the virtual interface. That's VLAN. We're going to conft interface VLAN 1. So configure the switch with second last IP address. So 192.168.1. One 20 broadcast address here is 120. 125. One no shut you can check and see. Yes, it has been configured. You go back to switch 2, enable show IP interface brief. Here too we do the same. Conft interface with plan 1 IP address 192.168.1. What's the last? 253. 253, 255, 255, 255, 128. No shot. Now verify that all devices can ping each other. Now let's see, can the device ping itself first? 192.168.1.1. Can you ping yourself? Yes, it can. Can you ping PC2? Let's try. What's PC2's? $129. I ping 129. No, it cannot ping 129. Okay, so why is that? Because we have not set a default route, default gateway. So for PC1, the default gateway for PC1 will be the IP address of this router at this interface, at this inbound interface. That is 192.168.1. I think 126. Let me confirm that. Yes, 126. Yes. Now that we have that, let's see if we can ping. Still unable to ping. We will go here. Let's put the default gateway on PC2 as well. One nine two one six eight one. What was this again? Two five four. 192.168.1.254. Let's see if now we can ping PC2. Let's see if we can ping the switch. What was the switch's IP? We can ping the switch. Let's see if we can ping the gateway. Of course, we will be able to ping that. Let's see if PC1 can ping the switch PC2 253. Let's see if you can do that. It cannot do that because we need to configure the default gateway on switch. So let's configure default gateway IP default gateway. we are going to use the same IP address of that interface, 192.126.25.25.128. Yeah, we don't need the subnet mask here. So save this and let's go back and see if we can now ping that. This. Now let's configure this first. The gateway of this route of this switch as well. IP default gateway 192.168.1.254. I think that's it. 254. Yes. Now we can go back and see we'll be able to ping that switch 2. Yes, the first time out is because of ARP. So now we're able to ping switch 2. So verify that all devices can ping each other. So we just did that. This device can ping all of them, and if it does, it means they too can ping all of them. So that was it for the first lab concerning subnetting. I will try my best to explain better in the subsequent videos how subnetting works. Thank you for watching. If you watched to this point, interesting stuff. See you in the next video.